So this lesson is on percent change. You guys know already that this is one of the most common math topics that you see in real life. This deals with taxes and discounts, tipping at restaurants, all percentages, right? And we saw in the last lesson that exponential functions, one of the things that they can model is percent growth or decrease. So it never hurts to review this topic. A lot of students, when they get to me, are pretty weak on this. And I think the reason is a lot of teachers teach this using a bunch of formulas that are hard to retain, right? So here we're just going to really focus on understanding the relationships that we're representing when we use percents. So we have this problem about discounting a pair of headphones. I used to use this problem, but it was about Beats headphones, but that's a little out of date now, and now it's about AirPods. So we're going to use this problem to try to understand the relationships we're representing here. So the first key takeaway is that percentages always represent a multiplicative relationship. And this is different from a lot of the math that we do, because a lot of the math we do is a linear relationship where we're representing repeated addition. Here we're representing multiplication. So the question you need to be asking yourself as you tackle these is, what do we need to multiply by? Right? So to discount these headphones, what are we multiplying by? And the way that we can tackle a lot of percent problems is by multiplying by 1 plus the rate, 1 plus r. Okay, so the reason we're using this 1 is percentages. Percent, cent means 100. The 1 represents 100%. And then the R represents the change. Okay, so here in my AirPods problem, we're discounting by 25%, right? So 1 plus R, well, discount means the price is going to go down, so that R is going to be negative. It's going to be 1 minus 0.25. And you guys know, I'm sure, that 25%, we move the decimal place over twice, becomes 0.25. So we're multiplying times 1 minus 0.25. That gives us 0.75 is the factor by which we're changing this amount. So I'm going to do 0.75 times 159.99. And that gives me, and you can use a calculator for this obviously, 119.99. And I rounded a little bit there. But notice we're not done, right? So we want the price in the third week of the sale, and we're discounting by 25% each week. So we have to do this 2 more times. And that's where our second key understanding comes in. So a common error that I see is I'm like, okay, the price went down $40. So then I subtract 42 more times, and I think I'm done. The key understanding is that percents relate a part to a whole. So this second week, we're no longer changing by the same amount. We're changing by 75% of, or we're subtracting 25% of this new price, right? So I'm going to do 0.75 times my new price. And then to get the third week, I'm going to do 0.75 times whatever I get. So we'll do that math real quick. And what I get, and I have to round up a little bit, is 67.50. So I round to the nearest cent there, right? So notice the whole changes each time. So make sure you consider what the whole is every time you do a percentages problem. Okay, so those are our 2 key takeaways. So we're always multiplying when we're solving percentages problems, and we always need to consider what the whole is, because it's a percent of a particular thing, right? You may be thinking that I did this first problem in a dumb way, and I could use a shortcut. And if you're thinking that, you're smart, and you have internalized the last lesson well. So the way I can represent what we just did using an exponential function, notice we're representing repeated multiplication, right? So my rate is still 0.75. And I did that 3 times for 3 weeks. And my original value was 159.99, right? So that is the same math that we just did. It's a little shortcut, right? And we get, again, 6750. So if you're thinking that, you're right. And that is definitely a fair and easy way to do that problem. Now, I can switch this up a little bit. We're going to tackle a couple of different examples. And I want you to kind of set these all up the same way. So here we have a different set of headphones cost $69.99 after a discount, and we want the original price. So my 20% discount is 1 minus R, right? So 1 minus 0.2 is 0.8 is my discount. But this is not the original price anymore. This is the new price. So the way I would set this one up, right, is I'd multiply by that 0.8, but I don't know my original price. And I'd do set that equal to my new price. And you can obviously solve that by dividing 0.8 on both sides. I'll let you do that on your own because that's math you know how to do, right? So if we're missing the original price, that tells me I need to solve an equation if I want to set it up the same way as our original problem. Same thing here. Here we have a $130 pair of headphones discounted to $115. Here, we don't know what the percent is, right? So the way we can set this one up is we can be like, well, 130 times X, and that would be my change, is 115. And here I'll solve it, right? Because there's a little trick to this one. So what you get here is 0.885, and that's not obviously my percent discount. Remember, that is 1 minus R, which is 0.885. Okay? And you could solve this, or you could think like, what did I subtract from 1 to get this? And R is going to be 0.115, which is an 11.5% discount. Okay? So there's a little bit of an extra step to convert like my factor here, what I multiplied by, to a percentage. Okay. So notice these are all the same type of problem, but the unknown is different. So you have to do a little bit of thinking here to tackle these. But we're essentially doing the same math each time. The relationship is the same, right? So we're going to move on to one more context we see percentages in, but make sure your notes are complete before we do so. So here we're considering percentages a little bit differently. We're looking at the relationship between a part and a whole. So you've seen these types of tables before. This one's about pets, who likes what kind of pets. And we're talking about girls who like dogs. So girls who like dogs is here. The total sample is here. And notice percent of, what comes after of, is the total. So of is always a keyword in these percentages problems. So maybe draw a box around of, if that's helpful to you. So we said earlier percents are multiplicative relationships. When we have a part in a whole like this, the way we tackle this to figure out the percent, well, we know multiplication and division are related operations, right? They're inverses. So the way we find a percent in this case is we do part over whole. We're thinking what part is 12 of 50? And that ends up being 0.24, which you guys know is 24%. What percent of boys like cats? Here's what I want you to zero in on. The whole now is changed, right? So if you're thinking, I don't know, boys 9 over 50, that's wrong now. We want 9 over 22, right? Because we want the percent of boys. There's 22 boys, 9 of them like cats. So again, this relates to our key understanding of what is the whole, what are we comparing to, right? So 9 over 22, that comes out to, we get 0.4090, and we can move the decimal place over twice. That becomes 40.9% of boys like cats. Okay. So pay attention to what the whole is. And then here's an interesting thing we can do. So suppose there are 665 students in the whole school. So if we read the text, we asked 50 of them. We want to estimate. So that's one of the things these things are useful for, right? Is we can estimate by asking a small sample to save us the work of asking all 665 of us, right? how many would we expect to like dogs, right? Well, dogs, 22 like dogs out of 50. And that would give us 44% if we divided this out. So we could take 44% of 665, or, and you've seen this before, we could do this. Right, so part to whole on both sides, and then we can cross multiply and solve. You guys are also good at that, so I will give you that comes out to 292.6. So we won't cut any noble students apart into pieces, so we'll do 293 students. So we'll round up there.